Evan, if you jump to the next slide for me, we'll actually show you here the journey that we're all going to go through. I mean, we've all seen this, we've all done projects, and we know, right, cool, we started a discovery meeting, we move on to maybe a requirement side, we do the CAD design, we do drawings, we go through an approval process, maybe there's changes that need to be involved, and then hopefully there are complaints listed there, but let's hope that we never get to that stage. But now, yeah, this is the process that we need to follow. So basically, from here, this process, this full process, now there's nothing that we need to worry about in this instance where, hey, we have a different platform, maybe we're using different CAD. As I mentioned, that this collaboration is very seamless in the way it integrates with other CAD environments, other departments, all that kind of thing. So this platform allows that full suite through the brands like Innovia, which is your project planning, all to be easily used. You can go from this discovery process to the end of the change management side. So CAD isn't everything. There is a lot that happens around it, like the planning and the meetings and so forth. Now, one of the sessions that I found really informative was a session called A Design Review with 3DExperience. Now, just to quickly give you a breakdown on how that scenario worked out is, it was two guys. They were doing some consulting work for a client, and one of the designers flew cross-country and lockdown hit. Now, he was stuck with just his tablets. He had no CAD machine. He actually had to go out and buy a laptop from one of the local department stores. And what he could do is, because he was using SOLIDWORKS Connected, he could just download his SOLIDWORKS directly from the 3DExperience platform. We'll get into that a little bit later. And essentially what he was able to do is liaise with the client, create some minor designs, put them on the cloud, on the platform, have his designer who was back in the office create the necessary modifications and share that back to him via the platform. And that allowed actually a seamless transition between the discovery phase all the way up to the approval phase of the project. Right, so now, we've got this collaboration side with all these pieces in between, with the 3D modeling, the drawing, and that sort of thing. Yeah, but how does that work with the platform, and what are the different options we've got available?
Yeah, so obviously Byron's now mentioned like project management tools, change action. There's a lot to the platform we can't show in the session. It's simply too much. Every time a customer asks me, what's the platform? I tell them, do you have a day? Because then we can go through some of it. It's so much. But just to explain a bit on the CAD side, and I think this will expand it a bit more. So firstly, most of you will know desktop CAD, normal SolidWorks that you've already used. Now, 3DExperience has something called 3DExperience SolidWorks. Now, that's this connected one here in the middle. You might think, hey, these two look similar. You just copy-pasted that screenshot. Maybe I did, but it's because they're actually the exact same tool. Both of them can be connected to 3DExperience. The only difference is one is a license given via 3DExperience, the other one is a normal SolidWorks license. Now, to go a step further, taking this to a point of where we're looking at things like cloud CAD, where the future is going, where the industry is going, we can still pull in the same model. We can reference it, we can modify it, add in components, mates, mating, etc. And that's a completely different CAD system. Now, Byron showed you one example of that, but this can be really for anything. So it can be electric CAD with tools like Altium. It can be with things like draft site, if you have 2D drawings. So it's really flexible in the type of systems it accepts. But Byron, like we said, this is not going to be a 3DExperience showcase. So what kind of cool CAD things did you see at 3DExperience?
Yeah, so one of the things that really stood out to me, there was a two-part series done on mesh geometry. So the title of that was just working with mesh geometry. And this is something that really stood out to me is, I mean, we've all done those home projects where we've looked online, we found a object file or STL file that we've downloaded, we've thrown it into SolidWorks, and it's an absolute mess. It's a mission to use. None of the features work with it. And now that capability has actually been enhanced. And I personally didn't realize this. So essentially, there's just three types of bodies that you need to consider in this instance. Just to give you a quick background for those of you that are not aware, there is your classic burette body. So a burette body is something that SolidWorks creates, your general extrudes and all that kind of thing. It's what you see on a daily basis. Now, the graphics bodies, these are those STL files or the object files, or there's a new type that the SO have come up with, is the 3MF file. So that's the graphics bodies. They are a little bit limited in terms of features that you can use. Often 3D scan data comes like this, that sort of thing. And then third is your mesh B-rep bodies. Now these are bodies that are made up of solids or surfaces where they are made up of things called facets. So now anyone that's worked with any sort of mesh kind of knows facets are these little triangular kind of break up of the surface. It's annoying to work with. There's a lot of these small triangles, and it's a lot with the imported models and that sort of thing. But the main point is that you should remember that there's certain features that are not available with normal graphics bodies versus B-rep bodies.
Yeah, Byron, I've had like days of headaches just dealing with mesh data. So you've mentioned these different types, but like what can I actually do with this? How's this like helpful to me?
Yeah, so the one thing that did stand out for me is this 3D scan data. Now, we've all been down that road of getting a question, hey, what do I do with this 3D scan data? How do I actually work with this? Now, the video you're seeing on screen is actually doesn't look too bad. Now, I'll tell you one thing prior to the little bit of cleanup that we had to do on this is that 3D scan data is very noisy. It gets a lot of random little surfaces. And as I mentioned, you can see it's made up of these triangles. Now, can you imagine thousands of these triangles randomly spread out through your modeling space? It's just a mission to work with. So there's a couple of tools, notably surfacing, which is actually, I think, very widely utilized with the 3D mesh and the 3D scan data, where you can actually use it to clean up models that you get. So now just a couple of these tools that are used is the paint to select facets. Now, basically, there are a couple of selection filters that you can use with this 3D scan data, one being paint to select. It's essentially you take a brush, you brush over the certain facets, and you can do whatever you need with them. On top of that is your normal delete hole and delete face. And then there's actually a cut with surface. You'll see that there's a little block beneath this model. You can actually just somewhere use a cut with surface, and it's as easy as removing that piece of information. Then you have a good model to work with. You can create it into solid geometry and go on from there. All right, and then now just this next example that we've got here is, I quite enjoyed this model. It's something very unnatural that we would normally use. Those of us in the mechanical environment know we're normally working with gears and vehicles and aircraft and stuff. So I thought it was a cool little Batman model that we could jump into. And just to highlight a few key differences between 2021 and 2022 when working with these mesh B-rep bodies. So what you'll see in both instances, they have to be converted to mesh B-rep bodies. We can use those selection filters that I spoke about to create certain planes to allow us to work with these bodies correctly. But what you'll see is that on the left-hand side in the 2021 model is that you can actually you have to cut it in half, and then you integrate your extrudes and that sort of thing. And it's actually very difficult to work with because that merge result tick box. And Evan, if you want to just play that video again for me, is that you'll see that there's a merge tick box or merge result tick box, the one that we all know. And when you're creating those extrudes, it just doesn't allow you to do it. But with 2022, we have things called hybrid bodies, hybrid mesh bodies. And that's essentially the combination between a mesh body and a normal B-rep body. And as I mentioned earlier, there's certain features that are not generally available with the mesh bodies. However, now, because we can actually tick that merge result box with 2022, it allows you to use the normal fillet features and all that kind of thing. So you'll see on the right-hand side there, when you're trying to choose a mesh edge, it actually doesn't allow you to use those features. However, when you choose normal B-rep bodies, it'll actually allow you to use those features and will automatically be merged. So that is something that is quite nice from that side of things.
Yeah, and I think a big thing about this is we're obviously just showing you one example from 3DExperience World, and that's working with mesh bodies. There's so many sessions there, just general CAD tips that will save you time. Now, obviously, we're going to show you a few different things other than just CAD tips, but guys, go to 3DExperience World, sign up, look at all the recordings, and definitely next year, watch some of them live. I know it's US time, so it goes into the night, but you can always watch the recording the next day.
Yeah, 100%. Now, another one of those tools that I mentioned is this slicing tool. It's something that we're going to do maybe a little bit of a separate video or a blog post that we'll post for you guys. It's another really cool feature I found. Another one is this 3D textures. Now, we all know appearances, we all know how to add colors, all that kind of thing. But these 3D textures, the mesh geometry functionality allows you to actually take those appearances, specifically appearances in the grayscale height map kind of functionality, or gives you that functionality where essentially think of it like a map. You see a hill and it's got those rings indicating the different heights. That's essentially what it's doing with the grayscale map. So what you can see here is there's actually a tool directly called 3D textures. Now these 3D textures allow you to take that grayscale geometry and make it 3D, something that would normally be so difficult to create with normal modeling methods. And as you can see there, it's created the knurling, it's created these little dimples on the handle to allow easy gripping and all that kind of thing. And it is quite a simple thing to use. You select your appearance, you give it a bit of refinement, and you go from there. It's just that easy. All right, so now there's a few things about desktop CAD, but Ivan, you mentioned this cloud CAD. Now I know it's slightly different, but what about this cloud CAD that you can tell me?
Okay, so I said we're not going to do too many 3DExperience things. It was a little bit of a lie because some of the coolest stuff we saw specifically was for 3DExperience. Now, I'm just letting this play in the background. This is just normal cloud CAD, and everything you see here, it's sketching, it's extrudes, it's fillets, it's cut. It's stuff you guys will be familiar with. But what we actually want to show you is the stuff 3DExperience does that SolidWorks can't do or doesn't do. So before I dive into that, let me just explain a bit about what Cloud CAD is. So firstly, Cloud CAD is browser-based CAD. So that means there's no installation and it will run on any device. So as long as you have a browser on the device, it will run. That means Windows, Mac, Linux. It even means tablets and phones. So you could technically do tablets on CAD on an iPhone. We actually have a customer already using this with an iPad. And so this is something that's really possible to use even with devices we traditionally don't consider cloud devices. Now, one of the other things about this is because it's linked to 3DExperience, collaboration is made easy and data management is built in. And that's one of the tenets of 3DExperience, hassle-free data management. You don't have to go and set up a PDM vault or anything like that. From the start, everything works. You just upload your files, revision them, and so forth.
So now, Ivan, you mentioned that I can use it on any kind of cloud or any kind of PC now. You said this cloud CAD, and it sounds amazing, but now what can it actually do? Surely it's not just your normal SolidWorks, extrudes, cuts, that sort of thing.
So that's a cool thing. In SolidWorks, you have your sheet metal tab, your weldments tab, etc. And they've sort of done the same here, except they've split them into different apps. So if you're just someone that just does sheet metal, get the sheet metal creator. If you do structures, weldments, etc., dive into the structure creator. Or if you need the whole kit and caboodle, get the SolidWorks Cloud offer, and you have all the CAD tools you're used to, and then some additional ones like the 3D Sculptor, which is like a free-form clay-based modeling tool, as well as tools like 3D Render, which is a cloud-based render system. Now, let me show you some of the cool examples that we saw within 3DExperience. Now, this is a webinar done by Mark Rushton. He's actually the head of everything related to this cloud CAD, and he's showing us some of the cool features that you don't get in SolidWorks. Now, in this particular case, this is what's called design guidance. Now, you'll see this is done on an iPad, so just hammering that point home. But what he's doing here is he has two little spindles that need a support system. And he's just telling it, okay, design something for me to support these with a certain weight. Now, the system generates a shape for him that's kind of, a little bit wonky. You could 3D print it, or you could use a 5-axis CNC to make it, or you could use it as the basis for his design. So he draws a sketch on it directly in 3DExperience and uses that as the actual produced component.
So now, Ivan, you say that this can create these generative designs and that sort of thing, although the topology optimization, whatever it might be. Now, I know that is a simulation thing normally. I mean, you can create those sort of things with Sim, but really, I'm actually surprised it's in this CAD environment. It makes my life so much easier. It's actually such a powerful tool.
Yeah, and it's not a separate license. This is part of just the base X design license. So you can do something we call sim mode. where you actually make modifications based on simulation results. So it's not just simulation is a verification tool at the end of the design process. It can start being used throughout the design process to make your designs more unique, reduce weight, reduce costs, etc. Now, the next tool I want to show you is called Design Assistant. And that's exactly what it is. It's a little AI-powered assistant that helps you with your design process. Now, I have a little gear design here, and I want to add some fillets to that. So I'm just going to edit the component right there. And each of these little gear teeth need a fillet on it. So a little 0.1 millimeter fillet. Now, this is going to be a pain to try and select all of those edges. But let's start this process. So I click on an edge, and a little pop-up comes up, and that's the Design Assistant. I click on that. It automatically shows me what it suggests things I might need. So it selected all of those edges in orange. If I want to change that, I can press the gear icon, give it a bit more information. I'm quite happy with this, so I'm just going to press OK. It's going to select all of those edges, and something that might have taken me 5 to 10 minutes has now been done by this cool tool.
No, yeah, you're right. That's 100% really, really cool. But yeah, these lines are kind of parallel, they're the same length. It's not too difficult to do. Yes, it's a time saver, but surely there's something a little bit more complex.
Okay, so I hear you, Byron. Let's kick it up a notch. So let's take this a step further into sketching. Now I have a little part here, and I'm going to draw a sketch on the top face because I want to drill some holes for mounting. Now, normal sketching tools, nothing unique here. Just plot a little circle there in the corner and size it appropriately. Now with the Design Assistant, it's going to actually pattern that across the entire body with similar positions for that. Now, I don't know about you guys, but there's no pattern in SolidWorks that would have this level of intelligence on it. And that's really what I'm trying to get at. This is a really cool and powerful tool that does things you might not expect it could do.
Yeah, 100%. I mean, I knew AI was good these days, but it's kind of a little scary. I'm getting like Terminator vibes from these. But Evan, I've actually seen this before, but I haven't seen it on sketching. I've seen it on mates. So in this example here, like I said, we've seen this on mates, but there's a manual process involved with this, is where you create a couple of mates, and now I need to make this gear to these certain pins. Now, yes, of course, I can go ahead and use copy body, whatever it would be, or copy with mates and create this certain different examples of this. Now, but with Design Assistant, what I can actually do is, once I've created those baseline mates, it actually knows, hey, there's 2 other pins here. Maybe you want to actually add those, this body and the subsequent mates onto those 2 pins. And you can, of course, go and deselect and select the ones that you don't want, or the instances you don't want. But now on top of that, what I'm actually going to want to do here is take this gear, and you'll see there's a couple of pins just behind it. And now I can copy with mates. I can go and translate that body across, or copy the body. But with this Design Assistant, I can actually go and just select one of those circles, and it'll actually go, hey, cool, here's a gear. I can propagate that to the back pins. And then it again sees those subsequent 2 other pins and suggest, hey, do you want to create these this gear onto these different pins? You'll see now there's 5 instances. I can click OK, and it'll copy the body into those 5 different locations, or 6 different locations, and there you go, here are your gears. Now, that's something that would generally take you quite a long time.
Okay, that's cool. But in the spirit of one-upmanship, Byron, I'm going to take it even further. So moving away from the bit more traditional CAD, let's move into something called Pattern Shape Creator. Now, don't let the name fool you. Yes, it can make very cool patterns, but it's what we call an algorithmic modeler. Now, SolidWorks is a parametric modeler, and with that, you can change dimensions, you can even drive equations to update the model. But there's limits to how far you can take that. So let's take this example. I want to design a staircase, a spiral staircase, and I want to be able to let the steps be updated, the amount of steps, the length, etc. So first thing you'll notice, I've drawn a line, I've added in a point, and I'm going to add in another one as well. But all of this is actually in the feature tree here on the left-hand side. So it says line and point and point. So that's one of the key differences. Everything, there is no separate sketch item. Every single item in this is a feature tree item. That means every item we can drive with equations, we can drive parametrically. So that adds a lot of power to the system that you don't have with traditional CAD tools. So we're adding in two walls on each side, and we're just splitting those edges for the amount of steps we need. In this case, 12. Now, we just select it, and as soon as you select any item in this, it gives you a little pop-up as to the various options you have. Again, we just select the line tool and we say, between these two curves, create lines for them and just cut them off at the inner surface there. So already we're doing some things that are a bit more advanced than what you can do in SolidWorks. But let's do a little sweep here to get the start of those sketches. We're running out of capabilities here. So we're opening up what we call a node-based programmer here in the background. Now, this is actually something I found really cool. Now, it does look a bit daunting, but I've never used this tool before up until I watched this webinar. And literally an hour after watching the webinar, I was already drawing away, generating tools like this, generating geometry that I can update so easily. Now, if we look at the steps, they're kind of wonky, so we need to offset them a bit. So we're going to pull in a project node and just create some references here. I'm going to skip ahead a bit just so you guys don't have to look at this whole thing. But now we're thickening up the steps, and we're actually getting to the design that kind of looks almost done and ready. So skipping ahead just a little bit more, both walls are thickened. What we want to do now is, not everyone has the skill to use this tool. So we're going to add in a little step counter where people can say, let's take the amount of steps, increase or decrease it, and the model will update completely on its own without them having any CAD knowledge. So we've made it an experiment item. I'm going to hide some of the stuff just to make it look pretty. And then here on the experiment tab, we now have a little counter that we can increase or decrease to increase or decrease the amount of steps. You guys, Byron, isn't that kind of cool?
Yeah, no, definitely. But Ivan, I'm fairly sure with a little bit of effort, I can actually create this sort of thing. But now, surely there's something a bit more, maybe something that is a little more complex.
Okay, I hear you. I could have done that with SolidWorks equations. No one's going to be super wowed by that. So let's do this one. How long do you think it would take you to draw that strap? Hour, maybe?
Yeah, probably. It wouldn't be too difficult. A couple of sketches. The shapes might be a little bit of a pain, but I could get there. Simple wrap feature, easy enough.
Okay, and then the length of the strap updates, and someone wants a different type of pattern on it. What then?
Yeah, no, sorry. I think you're going to be on your own on that one. I think at that point, that's going to take way too long.
Okay, so let me show you that same methodology applied to this. And on top of that, we're applying it to a SolidWorks part. So this is the cool thing about these tools. They're fully bi-directional with SolidWorks. So anything changes you make within SolidWorks or within the Cloud CAD tools, they update both ways.
Yeah, man, bidirectional is a rather large word. I haven't had enough coffee for that.
Well, it's such a cool feature, and it's like the perfect word for it. But I get it. So let me explain it a bit. So firstly, we want to save this to the cloud. All we have to do, it's literally a one-click save. Go to the 3DExperience add-in on the right and press save. You can then open it up on the cloud, and we can start that same design process. So you'll see a similar interface to what we saw earlier with the tools down here at the bottom and the tools on the left-hand side. I'm not going to show you the whole process. Obviously, you sort of saw that with the steps. I'm just going to show you the end result in this case. Now, here we have our strap, and we've looked at certain design variables in terms of the outside hole count, the intermediate hole count, and then the middle hole count. So what I'm going to do is I am going to modify some of these. And like Byron said, updating this in SolidWorks, you'd have to redo the entire sketch. Whereas with here, all we have to do is update the numbers and it starts regenerating and rebuilding. So it takes about, let's say, 5 to 10 seconds to generate this, but that's still extremely quick compared to having to redraw this entire thing. Now, a lot of you might be thinking, okay, that's cool, but I don't do patterns like that. I do structures, we do solar roofs, etc. And that's the cool thing. Now, first of all, we can pull this back into SolidWorks. But the real nice thing here is this is applicable to any CAD application where you're sort of exceeding the limits of parametricity in SolidWorks. So let's say you have a design, it's almost the same every time, but it's different enough that you'd kind of have to redraw it every single time you need to put out a quote or anything like that. A good example is solar panel roof mountings. You could set up the entire shape, everything once, and just give it a few points where the roof mounts need to be, the amount of solar panels, and every time you need to get out a quote, you just generate up the system, change those values, and bam, everything is done. But it's a webinar with me in it, so all of you must know there's always going to be simulation involved. And again, we're just showing you some of the cool features. I really encourage you guys to go look at the actual webinars these are based on. We'll make sure the links are included in the blog post that's going to come out later this week, later this week, or early next week. Now, simulation, my pet project, it has to be here.
Yeah, Evan, I'll let you get away with it this time, but I'm definitely adding PDM next time.
That's fine, I guess. Now, when we're talking about 3DExperience simulation, it really gets to the core of something we call the digital twin. Now, SOLIDWORKS simulation is a very powerful tool. It allows a lot of types of simulations that allow you to interpret your results, verify your designs, and make design changes. But 3DExperience takes this a step further. So this is a phone that's been designed, and I'm just going to show you a little loop of a crash test or an impact test for this particular phone. Now, if any of you have used SOLIDWORKS simulation, this doesn't happen in SOLIDWORKS simulation. Things like crack propagation, damage to the items, all of that, that's very unique to the Simulia backing of these simulation tools. Let's look at another example. And I'm not here to show a bunch of examples. I'm just here to get you guys the idea that if you need to do virtual testing of your components to verify your designs, even make sure the design you have is the best one, then use tools like these. So in this case, we have a bottle falling. Oh, that's nice, that's cute. But actually, we're simulating the fluid on the inside as well, the sloshing of that fluid, how that's impacting the actual deformation of the bottle. So if you're in the packaging industry, you can use this for checking if dropping your bottle is going to burst or break it. But it's not just for that. It's pretty much for every simulation use case you can have. And I'm not going to show you more examples, but there's some base-end simulation roles that cover the standard simulations you're already doing. Obviously, the more advanced stuff, like I just showed you, for impact testing, post-failure behavior, that sort of stuff. Even electromagnetics and high-end flow simulation is part of this whole Simulia portfolio. Now, all of this is cloud-based simulation, of course. And one of the things I just want to sort of speak to is that usually when you have cloud-based simulation, you kind of have to pay for credits and tokens to simulate in the cloud. And that's not the case here. So you get included simulation tokens with this. It's with your simulation roles, 4 credits for the lower end stuff, 8 and 16 credits for the high-end FEA simulations, the high-end electromagnetic and fluid dynamic simulations. And if you need to move into even more complex stuff, you can go up to 288 cores. You can start using GPU solve capability. So really, you could go really fast with your simulations. And just to show an example, here we have a specific simulation, which is a drop test in this case. And you'll see the example there at the top. So this is already a very complex simulation. It will take a few days to solve, or at least a day to solve in SOLIDWORKS. Whereas in Simulia, it's about, for 8 cores, it's about 26 minutes. As soon as we push that to the cloud cores, however, that moves all the way into 16 minutes. So it's actually quite a powerful tool here. And we can go even higher to reduce that solve time. And it's all about getting a good turnaround time on your simulation so you can make design decisions based on the simulation results. Now, enough about that. Let's get a bit into topology optimization. So I showed you the stuff that's in XDesign earlier, but we actually have a bit more powerful tools than that within the portfolio.
Now, Evan, quickly, before you move on to that, firstly, that phone animation, I think everybody's got some PTSD from that, and we've all seen that in our nightmares. But you mentioned that there's this cloud solve capability. Now, what happens if there's somebody running around with an i3 Intel Celeron old PC? Can they actually still run these simulations without issue?
You're probably joking, Byron, but like if you're a Celeron, whatever, it doesn't matter. You can just push everything to the cloud solve. You could even shut the PC down, hit solving in the cloud, and you can review the results on your tablet, on your phone. You're not restricted to using specific devices to view the results. And that's also the nice thing. You don't need the simulation license to view the results. So all of your colleagues can have a look at the results, even without having one of the simulation licenses. Now, just finishing up everything on the topology side, we are running a bit out of time here. The general methodology with topology optimization is you sort of draw a very blocky shape. You give it your constraints, things like where the forces are, where the fixtures are, and it gives you this sort of blobby shape like we saw in our previous example. Now, what makes the more advanced tools within 3DExperience more useful is that we can now actually take that further. So let me show you a bit of what that means. So here we have a SOLIDWORKS design, and I'm going to skip through this because we are running a bit out of time. But we're uploading, saving that into 3DExperience and opening up the generative design tool. Now, we're going to add in fixtures, tell it, okay, we want to keep these portions, just going to skip ahead a bit, and tell it we want to maximize stiffness while reducing weight. So just a few more skips ahead, applying material, and here we go. So we're going to run this simulation, and what it's going to do on its side is say, okay, these are where the forces and the stresses are. So let's start adding or removing material. And there it runs a few iterations, and it spits out a result like this for us. Now, this is usually where most of these tools just sort of end. You use this, and then you either have to design something completely new based on this, and you have to sort of reference that in your CAD. It's very difficult to do. Whereas with tools like this, we can actually use that as the basis directly within this tool for new design features. So if I just skip ahead here, we've done a comparison analysis, and we can now go ahead and actually start drawing on this particular design. So adding in extrudes, actual machinable features that we can then use in our final design instead of this sort of wobbly, knobby shape that we sort of get. And there we go. Obviously, this is a high performance part, so it still has a level of organic nature to it, but it's much more machinable. These are standard CAD surfaces that we can reference. And in general, it's just a really powerful tool. And that's, I think, what we want to get at with a lot of the stuff shown at 3DExperience World. There's really cool tips and tricks. There's really cool product showcases. And I encourage all of you just to go have a look and see what might be, what niche you aren't filling, what problem you aren't answering with one of these tools, or perhaps just with a methodology with the existing tools you have, like the mesh showcase we did earlier. Now,
yeah, for sure.
I don't know
if you have anything more that you want to add on to that.
I think, I don't know if there's any questions specifically regarding this. Obviously, like we've said, we're going to make sure all of the sessions we used are linked in the blog that's going to be posted, and the blog's going to go into a bit more depth on specific topics. Perhaps not these ones, slightly different ones, but it's all going to be within there. So I'd encourage you guys to go check that out.
Yeah, and then just from my end as well, of course, the content that you guys saw today were snippets from the 3DExperience World. As Johan says, there's I think 289 different sessions that will definitely fulfill some interest that you guys might have. So, of course, credit goes out to all of those guys that created this content and actually allowed us to create this this webinar for you guys. And again, the blog post will be up either later this week or early next week. There will be some hyperlinks in there to the different sessions that you might be interested in. So from my side, thank you very, very much for attending. Johan, thanks as always. Enjoy your rest of your day, guys.
Thanks, everyone.